this is the final thing I'll say. My research really looks at monkeys and why monkeys are resistant to HIV. And so, just looking at human cells, and these are cells from Rhesus monkeys. These are a type of old world monkey which is found over in Asia. We've known, I will say that we've known for many years, we've known since the middle 1980s, that monkeys are resistant to HIV. And this came out of studies to test HIV vaccines and drugs. We realized that if we take HIV and we infect the monkey, the virus doesn't replicate, and the monkey doesn't get AIDS and doesn't die. Monkeys are infectable with SIV, the simian immunodeficiency virus, but they're not infectable with HIV. And we think that this is important because monkeys have evolved different ways to become, different immune mechanisms to become resistant to these different types of viruses. If we can understand why the monkey is resistant to HIV, we should be able to make humans resistant. So if you look at human cells, if we take an HIV virus that expresses a green fluorescent protein, 100% of human cells are infected, but less than 10% of the monkey cells are infected. So it's a very strong block. And I spent many, many years and found there's a protein called TRIM5a, which interacts with the HIV capsid and basically causes this capsid to fall apart, thereby ending the HIV, thereby preventing HIV from replicating in monkey cells. And it turns out that humans also have TRIM5a, but we have there's one amino acid difference. There's one residue that's different in human TRIM5a compared to the monkey version. And this amino acid in the human version causes the human TRIM5 to lose its antiviral activity against HIV. So if you could just change that one amino acid, even if you could just delete that one amino acid, you could then theoretically make humans resistant to HIV. And we can show you that if you take human cells, and if we express, this is Rhesus monkey TRIM5 in the human cell, those human cells are completely resistant to HIV. Whereas this is just a control vector. If we don't express Rhesus monkey TRIM5, those human cells are completely susceptible. So it's a very, very strong and potent block to HIV. So I just leave you with, thinking about, the future and where we go from here. I think it's going to be a long time until we make an HIV vaccine. There really aren't many good candidates out there right now. We have achieved a lot in terms of developing drugs, but the drug pipeline is really slowing down. We probably aren't going to develop that many new drugs over the next few years. We've learned a lot in terms of prevention strategies that work and ways in which you can work with the community and do behavioral change and communication. We need to invest more in those. And we really need to invest in better primary healthcare systems in developing countries. So, I encourage you, I love working over in Uganda, and my parents lived for 3 years in Nigeria, and I lived for 13 years in South Africa, and my sister lives in Ethiopia. So my whole family has spent a lot of time over there. If you get the chance, if you're thinking about, career change or, midlife crisis or something, you say, you know what, Africa is a great place to go. And there's so much, there's a lot you can do over there. It's a great place to work. And so I encourage you, even if you don't, take a year or 6 months or something and go over there and work if you can. That's all I have. I'm happy to answer any questions.